All right, let's dive right into this explainer and demystify the underground debate literally every homeowner dreads but absolutely needs to understand. Sewer pipes. Sure, it's not exactly the most glamorous topic for a dinner party, but when you're suddenly staring down a massive, unexpected excavation bill, it instantly becomes the most fascinating subject in the world. So today, we're going to look closely at the data and figure out what actually matters when it's time to dig. Clay or PVC? Which one actually lasts longer? We're pitting these two heavyweights against each other to see what truly survives that hidden, kind of chaotic ecosystem right beneath our feet. I mean, down in the trenches, these pipes aren't just moving water, they're battling the elements. They have to survive soil movement, heavy traffic loads, aggressive root intrusion, and the massive physical stresses of the trenching and backfill process itself. So, who wins the durability war? Let's figure it out. Section 1. The Great Sewer Showdown. Meet the contenders.
So, looking at clay, it boasts this crazy upper limit of 50 to 100 plus years when it's perfectly supported. I mean, that is a massive amount of time for underground infrastructure. The data shows that in a pristine, well-supported setup, no cracking, no chronic water infiltration, clay can easily hit that century mark. PVC, well, it's typically designed for about 50 plus years in modern systems, but, and this is a big but, those numbers, they're really just theoretical maximums.
What we really have here is a battle of two completely different structural philosophies. On one hand, you've got the rigid, time-tested nature of clay. It's incredibly chemically resistant, but its survival relies entirely on its physical structure staying completely intact. On the flip side, PVC brings this flexible, modern approach. It bends instead of breaking. And that flexibility is a huge deal, because it lets PVC tolerate minor ground shifts without just snapping in two. Two completely different ways of surviving a really harsh environment.
Moving on to Section 2. Strengths and fatal flaws.
Because nothing underground is invincible. You've got these invisible villains constantly testing your plumbing. The earth naturally shifts, you have heavy traffic pounding down from the street level, and thirsty tree roots act like slow-motion crowbars actively seeking out tiny cracks for moisture. Combine all that with the intense physical trauma of actually digging the trench and burying the pipe, and you're looking at an absolutely relentless environment.
And when all that pressure builds up, each material hits its breaking point in a unique way. Clay's kryptonite is physical cracking. If the dirt beneath it isn't perfectly smooth and supportive, or it gets hit with a heavy downward load, it cracks. The joints pop open and roots just flood right in. PVC is completely different. It usually fails because of bad backfilling or poorly assembled joints. That leads to impact damage right from the start, weird sloping issues, or leaky joints, rather than the plastic itself naturally wearing away.
Which brings us to Section 3, the real deciding factor.
And here is the massive plot twist. The true champion isn't actually the material you pick. It's the quality of the installation. Seriously, our source text is incredibly clear on this. The single biggest predictor of a sewer pipe's lifespan is how it was put in the ground. The most honest answer to which lasts longer is simply the one installed by a crew that actively prevents stress concentrations and stops water infiltration from day one.
Even a pipe rated to last 100 years will completely fail if the construction is sloppy. Think about it. If the bedding underneath isn't perfectly supportive, the pipe is practically doomed. If the dirt thrown back into the trench isn't compacted right, you get massive external stress. Got the wrong slope? Now you've got stagnant water accelerating wear and tear. And poorly sealed joints, which is a really big deal for PVC, means you are guaranteed a leak. Bottom line, if the trench isn't built right, your wallet's going to take a massive hit no matter what material you bought.
This completely explains why modern contractors are all in on PVC for new replacements. In the real world, it's just way less prone to brittle cracking under normal residential stress. But hey, don't just write off an older clay system. If you've got uncracked, deeply supported clay that survived decades without a major stress event or joint separation, it has remarkable longevity. You shouldn't just rip it out just because it's clay.
All right, final section. Section 4, how to choose wisely.
So, what's the game plan? You really have to shift from just picking a pipe off a shelf to designing a holistic, durable system. First, look at the damage you have now. Are we talking one localized crack, or is the whole line deteriorating? Next, match your new pipe to the exact soil type, frost depth, and settlement risk in your yard. Third, and this is absolutely critical, demand proper trench details and approved fittings from your contractor. As we've seen, the trench matters just as much as the pipe. And finally, make sure you're planning a root-resistant design right out of the gate. Because before anyone starts digging, you have to know exactly what your specific backyard ecosystem demands. That is literally the only way to avoid digging it all up again in 10 years. Ultimately, this isn't just a basic debate of clay versus PVC. It's about the whole package, the pipe, the joints, the bedding, the slope, the whole shebang. So I'll leave you with this final thought to chew on. What exactly does the earth in your yard demand, and is your installation plan genuinely ready to handle it? Thanks for exploring this with me on this explainer, and hey, may your pipes flow freely for decades to come.